Welcome back. In this video, we are going to solve problem 7-3 that is taken from chapter number 7, Internal Forces, and book name is Engineering Mechanics, Statics and Dynamics by R.C. Hibbeler, 14 edition. So statement is two beams are attached to the column such that structural connection transmit the load shown. Determine the internal normal force, shear force and moment acting in the column at section passing horizontally through point A. So you can see this is a column and these two are the beam that are connected with this column here, here and here. And the transmitted loads is shown here. It is 16 kilonewton. This is 23 kilonewton downward, and this 6 kilonewton and 6 kilonewton acting horizontal. So you have to determine the internal loadings or internal forces at A when a section pass through point A horizontally. So let's start with the solution. As you cut this beam at section A or a plane passing through point A horizontally, so at this point A you will be having a normal axial load which will be represented as NA. So I will take it like this, NA, and along with that you will be having a shear force which will act horizontally, and that shear force is like this. It will be like this horizontally. It will be equal to VB, and as well as there is a moment which will act like this. There it will be like this, and this moment will be equal to MA. Sorry, this is also VA, not B, because it is passing through A. Now you have all these forces, so we will find them one by one. So starting from the first one, we will apply the equation of equilibrium that sum of all forces along x direction must be equal to 0 and force toward right is taken as positive. So here you can see you have three forces. One is this 6 kilonewton load that is acting positive direction, so it will be plus. The second one will be this one, -6, that is in opposite direction to what we have selected. And this VA is also toward the left. Their sum must be equal to 0. So I can write it as -VA -6 plus 6 is equal to 0. So from here, we will get that shear force at point A is 0 kilonewton. Now we will find the second one by applying the equation of equilibrium that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see this first one, 16 kilonewton load that is acting downward, so -16. This 23 kilonewton load that is also acting downward, this is -23, and this NA is normal axial load which is acting upward, so it NA will be equal to 0. So from here you will get this normal axial load NA is equal to plus 16 plus 23, and from here you will get that NA is equal to 39 kilonewton load. Since this is positive value, it means that our assumed direction of NA is correct. Now the last thing that we are going to find out is this moment about A. So for that we will apply equation that sum of all moments about point A is equal to 0 and taking the counterclockwise moment as positive. So about point A, this moment is MA, which is taken as counterclockwise internal movement at point A. So I will write MA. The second moment is due to this load, which is 16 kilonewton load, and you can see the perpendicular distance between this load and this load is this one, which is 30 plus 125, which is 150, and 150 millimeter is actually in meter, it is equal to 0.150 meter. So I will show you this load into perpendicular distance. This is producing counterclockwise movement, so it will be taken as negative. So I will write it, sorry, this is not 150. 30 plus 125 is 155. So make it correct. This is 155. So 155 millimeter is actually 0.155 meter. And I will write this is producing counterclockwise movement. So 16 multiplied by 0.155. Now the second movement is due to this 23 kilonewton load, and perpendicular distance is this one, which is 40 plus 125 is 165. And 125 plus 40 is 165, and 165 is 0.165. So I will write 23 multiplied by 0.165 meter. And you can see that this load into perpendicular distance, this is producing clockwise movement about point A, so it will be negative. The last thing is that you can see this 6 kilonewton load that is acting horizontally. They are non-collinear force, and they will produce couple because these forces acting in different plane and in opposite direction. So it will produce couple or rotating movement. So this will be negative. So I can write it as this will be minus 6 multiplied by a perpendicular distance between them is 185 millimeter, which is 185 meter, and their sum must be equal to 0. So I will calculate one by one. 16 multiplied by 0.155 is 2.48 minus 23 multiplied by 0.165. This is minus 3.795, and minus 6 multiplied by 0.185 is minus 1.11 is equal to 0. Now 2.48 minus 3.795 minus 1.11 will give you 2.ma minus 2.425 is equal to 0. So here we will get this ma will be equal to 2.425 kilonewton into meter. So what we are getting is that you are getting internal shear force, internal normal force, and internal movement at point A, which are the answers of our this required problem. And with this, it was all about this problem 7-3. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon. And if you have any question, you can ask me in comment section. Thank you for watching.